So here we run into our first problem that's a little bit different. They tell us what we want in the future. They tell us that we want $1,000 at time equals 3. And the question here is, at what rate should we be depositing money? So kind of, pennies at a time idea, but how many dollars per year should we be putting in if the interest is 5% if we want this amount of money after 3 years? And so let's just kind of remind ourselves what the formulas are that we have. The first formula is that the present value is equal to the integral from 0 to m of s of t e to the negative r t dt. And the other formula is that the future value is equal to the present value times e to the r capital M. Now, what are the different numbers here? Well, this 1,000, that is my future value at this value for M. This is obviously my R, and then from here we can start to fill some things in. And now if you notice, you fill in here, you wouldn't have much. We don't know the present value, we don't know S of t, that's what we're trying to find. All we know is R and M. And so we're a little bit of a loss if we start here. But if we start with this formula, start here, we will be able to actually solve for something useful. So we know that 1,000 is equal to my present value times e to the 0.05 times 3. So now you can solve for the present value by doing 1,000 divided by that e, and then we'll know that the present value is equal to $860 and about 71 cents. But remember not to round until the end. And so this is the amount of money that if you deposited at time equals 0, and this was the interest rate, you'd end up with this after 3 years. Now, how do we use this to help us find our income stream? Well, we can come here and say, well, I know that I need $860 and 71 cents. I'm putting that in for PV. And then I will leave from 0 to m. And I know S of t is going to be constant. So rather than writing S of t, I'm just going to write C. And then I'll put in the rest of the values. So e to the negative 0.05 t dt. And sorry, this was not m. This was in fact 3. So from here, I can actually do this in my calculator if I remember that when I multiply by a constant value, I can pull that out. So I'll have 860.71 is equal to C times the integral of 0 to 3 e to the negative 0.05 t dt, and then I'll end that square bracket. So this thing in the brackets, you should do this in calculator. All right, this is one you could actually do by hand. Remember that the integral of e to the kt is 1 over k e to the kt. But if you did this in your calculator, you would find out that this is equal to c times 2.78 about. And so to solve for c, you would just divide. We would find that c is equal to about $308.96 per year. So the whole way we solved this was just simply by looking at the two formulas I knew and just filling in what I could. Now the last question here is something you'll probably get in your web work or something like that, is if you wanted to deposit the money in a lump sum rather than as a stream, how much would you deposit? And so this is actually the definition of present value. It's saying present value says if you put this amount of money in at the beginning as a lump sum, you'll have the future value at your end time. So this is really just your present value, which you solved for in the last problem already, so we don't need to solve for it again, which was 860.71.